Your base is growing fast, you need more iron, more copper, more everything, but belts can only take you so far. Running halfway across the map to grab resources, you quickly realize that's not gonna work for long. It's time to learn trains, and in this video I'll show you step by step how to use them to move coal, iron, copper, stone, even uranium ore and sulfuric acid. We'll start simple, how to loot basic resources like coal and iron from your mining outpost and bring them straight to your smelting area. No complicated circuits, just the clean efficient basics to get you rolling. Then we'll take it up a notch. I'll show you how to transport liquids using fluid wagons. So if you're new to trains in Factorio and want to unlock the next level of resource transport, this guide is for you. Let's build it together, one track at a time. All resources patches are scattered all around the map, further and further away from the main base as the game progresses. It will make it quickly impossible to carry those resources entirely via belts. The solution to transport those resources will be to use trains. Trains are a big topic, but you will quickly see how to use them to transport resources in a simple manner. Advanced belts and inserters will be used, but less advanced ones will work as well. When mining ores, coal, stones or uranium, the quantity of resources produced varies depending on the size of the ore patch and also its depletion level, as patches only have a limited amount of resources. That will affect the production rate and is very likely you will end up with more resources on some belts than others. This will cause having train cars fully loaded before others and increase the time a train needs to wait at a stop. Or it will leave with cars that are not fully loaded. To solve this problem and ensure all the belts have the same quantity of resource, you can use rebalancers. Here is a rebalancer for 4 belts. Each belt then supplies 1 car by using 6 inserters. 6 inserters is the maximum number of inserters a train car can have on each side. Here again, you need to ensure the belts are evenly split between the 6 different inserters. For that reason, you can use 2 splitters, one after the other, so it will divide the input resource quantity by 8. Only 6 8 will be delivered to the inserters, and the 2 8s remaining will be reinjected in the incoming resource quantity. That way you can be sure each inserter receives the same quantity of ore. To get the 4 different belts delivered to 4 different train cars, underground belts will need to be used. Ores can be moved directly from a belt to a train car with an inserter. Unfortunately, it is very likely the inserters will be faster than the belts, meaning that the train will need to wait longer because of the belts being too slow. To solve this problem, chests can be used as buffers. A more advanced chest can carry more resources, but any chest will help with solving this issue. One inserter will place resources in the chest and another one will place them in the train car. The more inserters delivering resources into the train car, the faster the train will be full of resources. The number of inserters will affect the time a train needs to stop as well as the speed of the inserters and the number of items it can carry. To reduce the time a train remains at a stop, you can therefore increase the number of inserters to a maximum of 6 or 12 if you build chests and belts on each side of the train. You can use faster inserters or research technologies that allow your inserters to carry more items at a time. Let's see how much of a difference it makes to use a single side or 2 sides to load the train. Similarly to loading, unloading faces the same problems and the same solution. To rapidly unload the train and not be slowed down by the pace of the belts, chests should be used as buffers. Slower inserters can be used to move the resource from the chest to the belt as long as they are fast enough to fill a single belt. Otherwise, there will be gaps on the belt. Here you need to make a single belt out of 6. To do so, 3 splitters can be used in this way. Underground belts will also be used so you can have 1 full belt per train car. The fastest inserters available should be used as well to unload the train to minimize the time each train has to stop at the station. Minimizing the time a train has to stop at a station makes it more efficient, meaning it can transport more resources. Let's see how much of a difference it makes to use a single side or 2 sides to unload the train. Those setups will work well for traditional ores, but it won't be enough for uranium ore. This ore requires sulfuric acid, which is a liquid to run the electric mining drills, liquids that needs to be delivered. With pipes, you'll quickly run into the same problems as belts, as they can only cover a restricted distance, therefore trains will need to be used once more. The train car is different to transport liquids. It is a liquid wagon, and a pump is required to move the liquid in and out of the wagon. You would store the produced sulfuric acid in tanks in quantities large enough that it can fill all the wagon when the train arrives. The pump is fairly fast to transfer liquids, but the more pumps there are, the faster. You can use up to 3 pumps per fluid wagon to load or unload liquids. You can then deliver the sulfuric acid directly to the electric mining drills using pipes. Multiple approaches are possible, but an easy approach is to have a different train for the liquid and the uranium transportation. It will simplify the train's conditions and also reduce the risk of unconstrained unexpected issues. Similarly to the ores, buffers should be used to prevent any interruption in the production. Liquid tanks can be used to store liquids. If you need a bigger buffer, you can build more tanks. A single fluid wagon can carry up to 50,000 units of a liquid. Tanks on their side can only store 25,000. It means you will need 2 tanks to store the content of a single wagon. You will need 8 tanks if you have 4 wagons. Trains can be moved manually, but it is better to get them automated, so they can work on their own. To do so, trains need to know when to leave a station and when not to. This can be achieved with conditions within the schedule tab. Conditions can get quite complex, but powerful automation can be achieved with simple rules. At your loading station, it is very straightforward. You only want the train to wait for its car to be full. To do so, you simply need to set the condition to full cargo inventory. At your unloading station, there are 2 reasons you don't want your train to leave. First, its cargo should be empty, and second, its locomotive should have fuel, or it could run out of fuel in the middle of a trip. For the second condition, you need to ensure a fuel is loaded. It can be achieved directly on the locomotives. Loading the fuel is simpler to do when unloading, because it's at your base, so the resource should be more easily accessible. To achieve this result, the following conditions need to be set at the unloading station. Empty cargo inventory to ensure all the cars are empty, and all locomotive fully fueled to ensure there is enough fuel in the locomotive. The end condition is important or it won't work. If you are facing issues with trains staying too long at a station because it is slightly unbalanced, for example, you can add another condition for time passed or inactivity, but it is less accurate and you should not need it. All those conditions are also valid for trains transporting liquids. When using a single train to transport both liquids and solid items, the condition will be a bit trickier. It is probably easier to consider one resource by station in the condition. That will reduce the risk of the train waiting at a station for no reason. For example, the train does not need to be empty of the liquid if it is full of the solid items. That will prevent the train from waiting to unload a resource that might not be so important. For example, if your tanks are full of sulfuric acid, your electric mining drills can work even if the train is not fully unloaded. The conditions need to be based on the resource, as the train transports different resources. So for the liquid, the content needs to be set to at least 50,000 per fluid wagon, as that is the capacity of a fluid wagon. And it needs to be set to at least 2,000 per car, as that is the capacity of a car. This concludes this video. I hope you find it useful, and see you soon for another one.